So, welcome guys. We'll be studying permutation and combination in this video. This is going to be a one-shot video in which I'll be covering all the basics necessary for permutation combination, which can be asked in your IMU CET paper. After covering all the basics, I will also cover previous year questions, so remember to stick for them. But the thing is, permutation combination is a conceptual chapter. There are very less formulas. To be precise, there are only 2 formulas, and majority of this chapter is revolving around concepts, which I'll be teaching you with the help of numericals. So please don't create a ruckus that we are only solving numericals, we are not memorizing the formulas. Remember, there are only 2 formulas, and the chapter is basically conceptual in nature, which will be taught with the help of numericals. If you work with me through all the numericals which I discuss in this video, then you will be in a safe position as compared to your fellow mates, because we'll be covering all the necessary numericals which are required to teach the necessary concepts which will help you in the final IMU CET paper. So bear with the numericals, and here we begin. First, I'll cover the basic theorems which everyone should know. Theorems. Okay, let's try to understand the theorems. There are 2 theorems. One is the additive theorem, second is the multiplicative theorem. Multiplicative theorem and additive theorem. Now let's try to visualize what is happening in this. Okay, look, there is a room. This is my room. This is one door, this is another door. Okay, so there are 2 doors, door A, door B. If I want to enter the room, in how many ways to enter? In how many ways can I enter this room? If you ask me, I can either enter from door A or I can enter through door B. So I have 2 choices. How did we calculate 2 choices? I wrote first choice, door A. Then I wrote second choice, door B. So technically I wrote one choice A plus another choice B, and I got 2 choices. So what we did, we added them. Whenever you have a choice, whenever the word or is used, if you have a choice or the word or is used, then it is additive theorem and we will add the things. So if I say choose a color, and your choices are, this is first choice, this is second choice, this is third choice, this is fourth choice, this is fifth choice. Now we have to choose a color. In how many ways can we choose a color? First choice, second choice, third choice, fourth choice, fifth choice. Now either this or this or this or this or this. So technically we are going to plus. So it will be 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5. So I have 5 choices. So I'll take another example. Let's say you are at station A and you have to go to station B. You can either go by aeroplane, or you can go by train, or you can go by car. So how many choices do you have? First choices of aeroplane, another choices of train, another choices of car, and I'm saying or. First is of aeroplane or train or car, so I'm using the word or in between. So we will add them. 1 plus 1 plus 1 is 3 choices. So overall you will be having 3 choices. I think I have spent enough time on this additive theorem. Now let's move forward to the multiplicative theorem. Now let's say I have a room. This is just a second. Okay, so I paused the video to draw this diagram. Now if we have a look at this, this is a room. This is door A, this is door B, this is door C, this is door E, this is door E. In how many ways can I pass through this room? In how many ways can I pass through this room? Now how many choices do I have? I can enter the room through A, I can enter the room through B, or I can enter the room through C. I can exit the room through D or I can exit through E. Now, if we talk about entrance, how many choices do I have for entrance? Either A or B or C. So I have 1 plus 1 plus 1. That is total 3 choices. Then if I talk about exiting choice, how many choices do I have to exit the room? Either D or E. So it will be 1 plus 1, that is 2. Now I am going to enter the room and exit the room. So I'm entering and exiting. Whenever I use the word and, whenever I say and, then we are going to multiply the two. 3 into 2 is equal to 6. Multiplicative theorem states that whenever you see the word and, whenever two things are done consecutively, you have to multiply. So whenever you use the word and, or there are consecutive tasks, consecutive means one after another, enter then exit, you don't have a choice, you have compulsion. Whenever you have compulsion, whenever you have consecutive tasks, whenever you have compulsion, then you are going to multiply the two numbers to get the answer 6. So I paused the video to write down the question in order to save some time. Okay, so now let's have excuse me. Now let's solve this question. Let's say this is my room and this room has 6 doors. This is my first door, second door, third door, fourth door, fifth door, sixth door. I'll name them A, B, C, D, E and F. So these are the 6 doors. A room has 6 doors. In how many ways can a man enter a room and exit through a different door? So if a man enters through A, then he cannot exit through A, then he can exit through either of 5, F, E, D, C or B. Okay, so first we'll talk about entering choices and then we'll talk about exiting choices. So when a man enters, how many choices does he have? He has A, B, C, D, E, F. This is the sample space. He has A, B, C, D, E, F, 6 choices. And when he is going to exit, if he came in through A, then he is left with only 5 choices. If he came in through B, then he has 1, 2, 3, 4, 5 choices. If he came in through C, then he has 1, 2, 3, 4, 5 choices. So if he comes in through one door, then that door becomes useless and he has only 6 more choice. He has only 5 left choices. So if he's entering through either of the door, then that door is removed from the exiting choices sample space. So now if he's entering through E, then he's left with 1, 2, 3, 4, 5 choices. So in order to exit, he has only 5 choices. He has to enter a room and exit the room. So whenever we use the word and, we multiply. So now the answer is going to be 30 choices. I hope this question was clear. I'll change the question a little bit. Now the question says, a room has 6 doors. In how many ways can a man enter a room and exit the room? Now this is a different question. Now the man can enter a room and he has to exit the room. Now the question is asking me, in how many ways can a man enter a room and exit the room? So if he enters through A, now he is inside. Now he has to exit. Again he has 6 choices. So when he's entering the room, how many choices does he have? He has 6 choices. He has all the 6 choices, A, B, C, D, E and F. He has 6 choices while entering the room. And exiting, there is no condition about exiting. So he can exit from either of the door, that is A, B, C, D, E or F. Again he has 6 choices. And we are using the word and, entering and exit. So we'll multiply. This time the answer becomes 36 choices. I hope the difference between the two questions was clear. Thank you. Oh, sorry, I'm just pausing it to write down the question. Then I'll meet you in this video. So I've written down the question. The question says you have 6 different colors. Now in your pocket, you have 6 different colors. You have to create a code of 3 colors. So let's have a look at the solution. You have to create a code of 3 colors. Okay, now these are the three places where you will put your colors in order to create the code. How many designs are possible? Let's say you have 6 colors, A, B, C, D, E, F. I'm naming the colors as A, B, C, D, E, F. These are the 6 colors. Now, how many choices do I have for the first place? For the first place, I have 1, 2, 3, 4, 5, 6 choices. Let's say I choose color E and I put color E over here. I had 6 choices. I chose E. Okay, now let's see. So, as I said, I'll repeat. For the first place, when I have to put a color on the first place, then I can either put A, or I can put B, or I can put C, or I can put D, or E, or F. I have 6 choices. Let's say I choose E and I put color E over here. I had 6 choices for the first place and I chose E and placed it over here. Now for the second choice, let's have a look at the sample space. I can put A, I can put B, I can put C, I can put D, or I can put F. Now I'm left with only 5 choices. Now let's say I put color B over here. Now I put color B over here. Now for the next thing, now I have A color, I have C color, I have D color, I have F color. I'm only left with 4 choices. Let's say I put A over here. So now I can put first color over here, second color over here, third color over here. After counting the number of choices for each place, I say for the first place I had 6 choices. Then I consumed one color, so I was left with 5 choices for the second place. Then I consumed 2 colors, so I was left with only 4 choices for the third place. So now after putting the first color, I had to put the second color. I didn't have a choice. To create a code, I had to put first color and I had to put a second color, so I will multiply them. After putting 2 colors, I had to put the third color. I didn't have a choice, so I will multiply them. 6 5s are 30. 30 into 4 is going to be 120. So the answer is going to be total 120 choice. Okay, now let's discuss this question. Find the number of 4-letter words. So I have to create a 4-letter word. Number of 4-letter words which are without meaning. So it is not necessary that the word must have meaning. It can be without meaning, which can be formed from the letters of the word rose. So my sample space is going to be ROSE, rose. Repetition is not allowed. So let's say if I put O over here, then I cannot use O. If I put S over here, I cannot use S. If I put E over here, I cannot use E. If I put R over here, R is also consumed. So this is going to be one word. Now the question is asking me how many different words can I create? So if we have to count the total number of words which can be created, then we will start by counting. I'll just reduce it. Yep, let's begin. So for the first place, I had first, second, third, 4 choices. I can put either of the 4 letters. Then 1 letter is consumed. I am left with 4 minus 1, that is 3 choices. For the second place, now 2 letters are consumed. 3 minus 1, I am left with 2 choices. Now, if I am left with 2 choices, now after consuming 3 letters out of 4, if 3 letters are consumed, I am only left with 1 choice. For the last place, down here I am writing the number of choices. So for the first place I had 4 choices, then 3 choices were left, then 2 choices were left, then I had 1 choice. So after putting first letter, I had to put the second letter. I didn't have a choice. I had to put the second letter. So this is going to be multiplication. 3 4s are 12, 2s are 24. So I had total 24 choices. Okay, this question is done. Now I'll change this question. Repetition was not allowed. Now repetition is allowed. Now let's solve it again with repetition being allowed. If repetition is allowed, now let's have a look at this question. The question remains the same. The question says find the number of 4-letter words with or without meaning which can be formed from the letters of the word rose. Repetition is allowed. So for the first place, I had 4 choices, either of R, O, S or E. So I had 4 choices for the first place, and for the second place, again I had 4 choices, and for the third place, I had again 4 choices, and for the fourth place, I had 4 choices. So the answer became 4 to the power 4. Okay, so now if anyone had any problem, then rewatch this question. Otherwise, I'll create an algorithm for what just happened. This algorithm for students who still have a doubt, this is an algorithm. ठीक है, देखो यार, now I will have to make you visualize what is happening in this question. ठीक है भाई, चलो आराम से समझेंगे, कोई दिक्कत नहीं. Either I can put R, or I can put O, or I can put S, or I can put E. So R or O or S or E. And in the second block, now again I can either put R, or I can put O, or I can put S, or I can put E. So or O, or S, or E. Then again in this I'm writing, and in the third block I can put R, O, S, E, and between these I have choice, either one will be placed. Then again for the fourth block, now I have the condition, and in the fourth block I will write R or O or S or E. So or will come in between them. So what is happening? 1 plus 1 plus 1 plus 1. This is 4, and means multiply. Then 1 plus 1 plus 1 plus 1, that is 4. And means multiply. 1 plus 1, 1 plus 1 plus 1, that is 4. And means multiply. 1 plus 1 plus 1 plus 1, that is 4. So the final outcome becomes 4 to the power 4. This is the complete explanation why there will be 4 to the power 4 choices in this case. I hope it was clear. Now let's move forward. Okay, let's read the question. It says there are 6 MCQs. Okay, so now I have 6 MCQ based questions in an examination. How many sequence of answers are possible if first 3 questions have 4 choices and the next 3 questions have 5 choices? Let's try to visualize what is happening in the question paper. Let's say this is my question paper. The first question, second question, third question. Now these first three questions have 4 choices. So first question has 4 choices, second question has 4 choices, third question has 4 choices. Now this says next 3 have 5 choices. So now next 3 questions have 5 choices. Now the next question has 5 choices, another question has 5 choices, and another question has 5 choices. Now we are asked how many sequence of answers are possible. So in order to attempt the first question, how many choices do I have? 1 plus 1 plus 1 plus 1, that is 4 choices. And for the next question I have 4 choices, and for the next I have 4 choices, and for the next I have 5 choices, and for the next I have 5 choices, and for the next I have 5 choices. So in order to solve this thing, I'll write 4 into 4 into 4 and 5 into 5 into 5. So the answer is going to be 4 to the power 3 into 5 to the power 3. Okay, now let's try to understand this question. How many 3-digit numbers can be formed by using the digits 1, 2, 3, 4, 5, 6? Let's have a look at the solution. We have to create 3-digit number. For the first place, how many choices do I have? 1, 2, 3, 4, 5, 6. 6 choices. Then, if repetition is allowed, there is nothing written in the question. That means repetition is allowed. So I'll say repetition is allowed, because question doesn't specify repetition is not allowed. And 3-digit numbers, if we count after 100, there is going to be another number 101, there is another number 102. So obviously repetition is going to be there in 3-digit numbers, and when the question doesn't specify, we have to assume that repetition is allowed, because that is how normal numbers are written. In normal numbers there is repetition. So if the question doesn't specify anything about repetition, we'll consider them to be normal numbers and repetition will be there. So for the first place I have 6 choices, for second place again I have 6 choices, for the third place again I have 6 choices. And we have to put a first digit, then and we have to put a second digit, and we have to put a third digit. So I'm using the word and, which means multiply them. So the answer will be 216 choices. Okay guys, now I'll do a little bit of change. What will I do? In this same question, this is done. This question is done. Now I'm changing the question a little bit to explain a different concept. What if the question said how many 3-digit numbers can be formed by using the digits 0, 1, 2, 3, 4, 5. Now out of these digits, how many 3-digit numbers can be formed? Again, I have 3-digit numbers, and now I will write the choices over here. Now for the first place, how many choices do I have? Can I put 0 over here? If I put 0, 1 and 2, what is this number? This is 12. This is not a 3-digit number. Question says 3-digit numbers. 3-digit. 12 is not a 3-digit number. So 0 cannot come at the first place. Otherwise it will become a 2-digit number. So for the first place, I don't have a choice of 0. I have 1, 2, 3, 4, 5 choices. For the first place, I have only 5 choices. Now for the second place, I have 1, 2, 3, 4, 5, 6 choices. Now for the third place, I have 1, 2, 3, 4, 5, 6 choices. Now I'll multiply 6 5 is 30 into 6, 6 3 is 18, 180. So now I have 180 choices, 3-digit numbers which can be formed by these digits. I hope it was clear. Now I'll introduce a different concept by the help of the same question. Now in the different question, what will I say? The question says the digits are 0, 1, 2, 3, 4, 5 and repetition is not allowed. Now most children fear this type of question. I'll say don't fear it. Just give me 4 minutes and I'll explain how to solve such questions. Okay, let's begin. The question is saying how many 3-digit numbers. So we have to create 3-digit numbers. How many 3-digit numbers can be formed by using the digits 0, 1, 2, 3, 4, 5. By using these digits 0, 1, 2, 3, 4, 5, repetition is not allowed. Now let's first talk about the first place. I'm talking about the first place. If I'm talking about the first place, how many choices do I have? I can put 1, I can put 2, I can put 3, I can put 4, I can put 5. I only have 5 choices. So I'm writing number of choices. I have 5 choices for the first place. Now for the second place, if I'm talking about the second place, in the second place I can put 0 also, but I have already used 1 digit over here. A digit has been used. It can be any digit. I have already used 1 digit. Out of these 5 digits, I have used 1 of them for first place. For first place, I have used 1 digit. So out of these 5, only 4 are left. Only 4 are left. Read this with me again. Out of the entire sample space 1, 2, 3, 4, 5, I have used 1 of them. I have used 1 digit for the first place. So out of these 5, only 4 are left. Now only 4 are left and this 0 is also left. 4 plus 0, I have 5 choices again. For the second place, I have 5 choices. Now let's talk about the third place. Now for the third place, if we look at this, out of these total 6 numbers, I have used 1 at the first place, second at the second place. So 6 में से 4 गया, 6 minus 4, I have used 4 out of 6. Sorry, I have used 2 out of 6. Sorry. Out of 6, I have used 2 digits. So 2 have been removed from 6. I am left with only 4 choices. So the answer will be 5 4s are 20 into 5, 100. So it is going to be 100 choices to make a 3-digit number. I hope this was clear. Okay. Now we have a different question. How many numbers are there between 100 and 1000? 100 and 1000. So if we are talking about numbers between 100 and 1000, that means the counting starts from 101, 102 and it goes on till 999. So we are technically talking about 3-digit numbers 101 to 102 to 999, and it says in which all digits are distinct. So we will not count 101, we will not count 999. We have to count 3-digit numbers with distinct digits. Distinct means different. So the question asked us how many numbers are there between 100 and 1000 in which all digits are distinct. So we decided to write them down, 101 to 999. Then on writing them down, I realized that 101 has a repeated digit, so this will not be counted. 999 has repeated digits, so this will not be counted. So technically we are counting 3-digit numbers which do not have which do not have repeated digits. That means which have distinct digits. So we are talking about 3-digit numbers with distinct or different digits. So I will create a 3-digit number, and on this 3-digit number, how many numbers are there between 100 and 1000 in which all digits are distinct? Now all the digits are distinct. So let's talk about the total sample space. Total sample space is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total I have 10 choices. So total I have 10 choices. At the first place, can I put 0? No, I cannot put 0, because if I put 0, it will become a 2-digit number. So apart from 0, I have only 9 choices. 10 minus 1. So I cannot put 0. So I have 10 minus 1 choices. 10 minus 1 choices for the first place. So if I have to write the number of choices for the first place, it is going to be 9. Now I am talking about distinct digits. So one number is already present at the first place. If I'm talking about the second place, one number is already at the first place. Out of 10, one digit is used. So 10 minus 1 digit, which is at the first place. How many choices are left? 9. Now if I'm talking about the third place, if we observe, 2 numbers are already placed in the number. 2 digits are already placed. Out of 10, 2 are used. How many are left? 8 choices are left. And on multiplying them, this is going to be our answer. 9 8 is 72 into 9. 9 2 is 18. 7 9 is 63, or 648 choices. So the answer is going to be 648. I hope this was clear. You just have to remember, 0 cannot come at the first place, but 0 can come at the second place. You just have to remember this thing. Okay, let's move forward to the next question. Okay, let's begin with the next question. Now the question says, how many numbers are there between 100 and 1000? So what does it mean? Between 100 and 1000 means 101, 102 till 999. So technically it is asking me 3-digit numbers. The question is asking how many 3-digit numbers are there such that 7 is in the units place. Now this is 100th place, this is 10th place, this is units place. In the units place we are fixing 7, and then number of choices. If I'm talking about a number of choices, 7 is fixed over here, so I only have one choice, or rather compulsion. I can only put 7 in the units place. Then in the hundreds place, now the question doesn't mention anything about repetition, so we will assume that repetition is allowed. We will assume the repetition is allowed because the question doesn't mention anything, so we will assume them to be normal numbers, and in normal numbers repetition is there. So if repetition is allowed, I cannot put 0 in the first place, 0 cannot come, but I can put anything from 1 to 9. So I have 9 choices. So I have overall 9 choices. In the tens place, I have total 10 choices, 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So I have 10 choices. So answer will be 9 into 10 into 1. That is going to be 90 numbers. I hope this was clear. 90 choices is the final answer. Now I'll change the question a little bit. I'll introduce in the question repetition is not allowed. If repetition is not allowed, then we cannot solve it like the way we did it. Now we will have to approach this question in a different manner. Now the question is saying, in how many numbers are there between 100 and 1000? Again the question is asking me how many 3-digit numbers are there such that 7 is in the units place. So 7 is fixed at the units place. How many choices? Only one choice, that is 7. Now if repetition is not allowed, let's talk about the 100th place. In the 100th place, total choices I had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total I had 10 choices, but at the first place I cannot put 0, else it will become a 2-digit number. I cannot put 7 because it is already used. So out of 10, 2 digits are already used. So I am left with 8 choices. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 choices. In the 10th place, how many total choices I had? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Total I had 10 choices, but I cannot use 7 because 7 is already used. Now out of these remaining 9, look, out of these remaining 9, 1 is already used over here. 1 digit is present at the 100th place. So out of 9, 1 more digit has gone. So I'm left with only 8. So I'm left with 64 choices. I'll explain this question once again. Let's have a look at this. The question says 7 is in the units place. So 7 comes in the units place. Now out of 10, 7 is gone. How many are left? 9. Out of 9, I cannot put 0. So 9 minus 1 is 8. Now out of 10, total 10, 7 is gone, and this is 7 digit is gone, and one more digit is gone, which is present at the first place. So out of 10, 2 digits are gone, that is 8. So I wrote 8 over here. 8 into 8 gave me 64 choices. I hope it was clear. Else watch it again. It will become much more clearer. Let's move forward. Okay, let's read the next question. A gentleman has 6 friends to invite. In how many ways can he send invitation cards if he has 3 servants to carry the cards? So let's try to visualize what is happening. I'll draw the figure for friends. A man has 6 friends. 1, 2, 3, 4, 5, 6. These are his 6 friends. And he has 3 servants. Now, for the first friend, he can either send first or second or third servant. So he has 3 choices. Now for the second friend also he has 3 choices. Now for the third friend also he has 3 choices, 3 choices, 3 choices, 3 choices. And we are using the word and. So we will multiply them. So answer will be 3 to the power 6. That is 729 ways to invite his friends by using these servants. Okay. Now let's look at this next question. It says how many numbers divisible by 5? Now what is the condition? Divisibility by 5. It means no matter how long the number is, the last place should either be 0, or no matter how long the number is, the last digit can either be 5. Either 0 or 5 is present at the last place, then the number is divisible by 5. We'll remember this condition. Now let's read the question. And lying between 4000 and 5000. Okay, if the number is lying between 4000 and 5000, that means 1, 2, 3. 4000, it is greater than 4000, but it is less than 5000. So it will be a 4-digit number. 4-digit number. How many numbers divisible by 5 and lying between 4000 and 5000 can be formed from the digits? Now we have limited number of digits, so repetition is obviously not allowed. Repetition is not allowed. No, I'm sorry. Repetition is allowed. Since the question says number is lying between 4000 and 5000. So if a number is lying between 4000 and 5000, we are talking about normal numbers. Normal numbers. There is no condition. We are talking about normal numbers. There is no condition. And since there is no condition in the question, so repetition is allowed. Okay, let's begin. Now if the number is lying between 4000 and 5000, so number is going to be 4000, then 4001, then 4002, and so on. It will go on till 5000. So as you can observe, in this place all the digits are going to be 4. So 4 is going to be fixed over here. 4 is fixed over here. So I only have one choice over here. Now if 1 is over here, let's look at the next number. In this place, how many choices do I have for the second place? In this place, I can put 4, or I can put 5, I can put 6, I can put 7, I can put 8. So I have 5 choices. When talking about number of choices, we can put any 5, either 5. Now for the third place, again we have 5 choices, either of 4, 5, 6, 7, 8. And when we are talking about the last place, if we are talking about the last place, then the number has to be divisible by 5. I can either put 0 or 5, but 0 is not in the sample space, only 5 is there. So again I am left with only one choice. So the answer is going to be 25 choices. Now let's discuss this different concept on a different question. How many numbers between 3000 and 4000? So if we are talking about numbers between 3000 and 4000, the numbers would look like this: 3000, 3001, 3002, and so on till 4000. So as you can observe, in this place all the digits are going to be 3. So 3 is fixed over here. Now if 3 is fixed over here, then I cannot use 3 because no digit being repeated. Now let's talk about the second place. In the second place, how many choices do I have? 4, 5, 6, 7, 8. That is 1, 2, 3, 4 and 5. I have 5 choices. Then a digit comes over here. Out of total 1, 2, 3, 4, 5. One digit is over here. I am left with 4 choices. Then in the next place, another digit is consumed. So out of 4, one digit is consumed. I am left with only 3 digits. 3 4s are 12, 5s are 60 choices. So now I will be having only 60 choices. Let's move forward to the next question. So now you must have seen a question of similar sort which says, in how many ways can 5 rings of different sizes be worn in 4 fingers? So I have 5 rings: first ring, second ring, third ring, fourth ring, fifth ring, and there are only 4 fingers: 1, 2, 3, 4 fingers. Now if there are 4 fingers, first ring has how many choices? 4 choices. And second ring has 4 choices, and third ring has 4 choices, and fourth ring has 4 choices, and fifth ring has 4 choices. So the answer will be 4 to the power 5. The same kind of question is also present in the paper where it is said letter boxes and envelopes. The concept is the same for both the questions. In that question, the letter or the envelope has to go in the letter box. These are the letter boxes and these are my letters. Let's say I had 3 letters and 4 letter boxes. First letter had how many choices? 3. Second letter had how many choices? 3. First letter had how many choices? 4. Second letter had how many choices? 4. And third letter had how many choices? 4. So we will multiply them. Answer will be 4 cubed, that is 64. I hope the concept is clear. So now let's try this question which says, in how many ways can 5 letters be posted in 4 letter boxes? So how many letters do I have? I have 5 letters: first letter, second letter, third letter, fourth letter, fifth letter. How many letter boxes are there? There are 4 letter boxes. Okay, so I'm having 4 letter boxes. If I have to solve this question, first letter has 4 choices, second letter also has 4 choices, and third letter also has 4 choices, fourth letter also has 4 choices, fifth letter also has 4 choices, first letter has 4 choices, and second has 4 choices, and third has 4 choices, and 4 choices, and 4 choices. So answer is going to be 4 to the power 5 choices. I hope the concept was clear. So with this we have covered the topic permutation. That was fundamental principle of counting. Now in the next video we'll be covering the formula, NPR, NCR and questions related to them. We will complete the chapter in the second part, or the second video. So make sure you subscribe and press the bell icon so that whenever I upload the second video, it is available to you. Okay guys, bye.